right, fantastic. Thank you all for coming. It's great being at Berlin Buzzwords again. So my name is Joe Christian. I'm the CEO of Hornet Dev. And at Hornet Dev, we build infrastructure, retrieval infrastructure for agents. And today I'm here to talk about agentic retrieval, or like Doug Turnbull calls it, agentic search. We prefer retrieval over search, but I'll explain that later on. Then talk a little bit about self-optimization loops. And this is my third visit to Berlin Buzzwords. This is my favorite search conference. It's very high signal to noise, lots of great conversation, lots of great people. I've been here to talk about the AI-powered semantic search, a story of broken promises. This was at the height of the vector database hype. That was a fun year. And later I talked also about using LLMs to kind of bootstrap relevancy and improve relevancy. And this year I'm here to talk about agents becoming the new user of search and infrastructure. So I think it's some nice heritage there, a topic that I'm interested in. And today I want to cover a few things. I want to talk about what actually agentic retrieval is. And then I will talk about relevancy, and that relevancy is still king, even if there's a new user. And then finally, I will talk about the topic of the talk, which is about self-optimization loops. Sounds good? Good. Agents. So first of all, I just watched one of the Microsoft keynotes and counted the number of times Satya said agents, and it was like a lot. And there's a lot of mystery around this, so I would like to just simply define an agent, and I turn to Simon Willison. I'm a really big fan of his writing, and if you're not following him already, you should do that, and subscribe to his blog and everything. I think he cuts through the hype, and really recommend. He has this definition of that an agent is an LLM agent that runs some tools in a loop to achieve a goal. I think that's a fair description of what an agent is. And by the way, how many of you are using a coding agent like a daily driver? Like everyone? Yeah, so then coding agent is a really good example of an agent. And how many of you are using a coding agent for not really coding, but something else? Good, that's a lot. So then you are familiar with that, so I don't have to explain that a lot. There's probably a lot of search people here already. I see Alessandro is here and Doug is here. And if you look at Wikipedia for information retrieval, like information retrieval is the task of retrieving resources that are relevant to some information need. So I might have an information need, like what dates are Berlin Buzzwords this year, right? That's my inner thinking about my information need. And then I can express this information need as a query. In this case, a very advanced query using a site operator, a phrase, and a year. And that's the query formulating, and that's what the engine actually sees. And then you have some kind of retrieval system that can take this query, this expression of your information need, and try to score and rank the corpus, and you get some ranked resources back. That's the thing there's a lot of people here that have been building for this for a long time, information retrieval. And it turns out that these agents also have information needs to achieve this goal that they have. For example, in coding, you've probably all seen how an agent is grepping through and using grep as a tool and grepping through your code base to try to understand the code base. You might have also seen how your coding agent is reaching for web search to search through the web to find some information. And these are all examples of an agent that has this kind of information need to achieve some kind of goal. Also, this obviously applies for proprietary data, your private data, maybe your data on your laptop, or your company data, or your organizational data that is not necessarily in the pre-training mix of large language models. And since we are in the definition phase, I also would like to define agentic retrieval. And for me, agentic retrieval is this process which is triggered and steered by the agent itself. It's not necessarily, it's not me expressing the query and executing the query. It's actually the agent itself that is expressing the query and performing the retrieval phase. That means that the agent really needs to look at the tool surface it has and decide if it needs some information that is not present in the current context window of the model. And the agent needs to turn this information need into a query. So similar to a human having an information need and expressing that as a query to a kind of retrieval system. And the agent harness is the stuff you put around the model. And this harness kind of decides how the model or the LLM interacts with the world, right? And how many of you consider ChatGPT as an agent, like the ChatGPT UI? Not that many. Actually, if you look at ChatGPT and ask it, like, what are your tools? It can, for example, run code in a sandbox environment. If you upload a PDF, it uses that sandbox and some utilities installed in that sandbox to parse and extract the information. So I consider actually ChatGPT as an agent. And if you go to ChatGPT and says, oh, please research all the nice vacation places in Greece, blah, 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 it can go out and use web search to search for information, gather that information, and get the task done. So I consider ChatGPT as an agent. And the harness needs to define a set of tools and how the agent can actually access the world, right? And I've included some examples here. You can, for example, let it have a human interface, which is more of a search, and you have a information need expressed as a query. Or you can, for example, have a full domain-specific language payload. Or you can express your search as code. I can get into that in the questions, or read documents. So all the things that the harness is doing is letting the model interact with the world. And this is one of the big questions that I struggle with a lot, and that is, what's the right tool abstractions for agents? And I made a silly comparison here. This is, on the left, Google. You type some query, and when you type a query here, there's a very complicated system behind it that tries to understand the query, try to retrieve information, re-rank, semantic understanding, vectors, embeddings, what have you. So that's the equivalent in tool is search query string and search response. Then you also have the advanced search page. How many of you have used actually the advanced search page? Dog cutting, maybe? A few. It's not so popular, right? It's even really hard to find. And here you have some more advanced operators that you can use. You can say which words should match. And the basic kind of translation for advanced search is to have a full domain-specific query language exposed to the agent. So the fundamental question is, like, should agents get the same type of search box UI or interface as humans? We'll see. Another interesting aspect of having agents as the user of retrieval infrastructure is, like I said, they have information needs to get some tasks done. That's number one. It's also the case that LLMs are a bit less lazy than humans, so they can type faster in a way. That means that they also can fire a lot of queries and explore the tool that they are given. And this is often performed inside the kind of task that you want to achieve with your coding agent. And then on the infrastructure side, I think this has some implications of how you optimize and how you put abstractions on top of the retrieval infrastructure itself to handle this type of new workload. And this is also a part where we at Hornet are spending a lot of time to kind of optimize for this type of new workload. This simply describes and it's very small, but it tries to compare a query from Querylog before there were agents, before there were LLMs. So the AOL search log that was released by AOL. Some of you are probably so young that you never heard about AOL, but it used to be a search company, and they kind of somehow released a log of 3 million real users searching. And the average query length is about 2 terms. I don't think the average query length today is much longer than that when you have a human typing. But if you look at BrowserCom Plus, which is a fascinating kind of academic benchmark for agentic search or agentic retrieval, and you look through that and you look at the queries that GPT-5 has typed out, they are quite complex and they're really long and they're using a lot of structure. And this type of workload is actually quite challenging for a retrieval engine itself to handle this kind of workload. So this 2-word query is quite easy from a cost and performance way to actually execute. But a longer query like this is much harder. It's actually, so we put out a blog post where we compare these 2 workloads, and it's almost 8.4x difference in the cost to serve this. So the shape of this new demand is quite challenging. And when I talk about retrieval, I don't talk about agentic retrieval or retrieval in only the sense of having an information need or a kind of a classical search task where you have an answer, you want to find an answer to something. But it can also be a part of simply some task like write me some code for presenting at Berlin Buzzword, right? Which is the kind of overall task. But to complete that task, the main agent, the main conversation, the main chat context window might fork out into a sub-agent that actually doing a lot of different retrieval methods, especially related to if it's code, it's you're searching your local code system. So the outcome doesn't necessarily need to be an answer. Then I will go into the next chapter, which is about relevancy and what relevancy looks like for the new user. And I mentioned the BrowserCom Plus dataset. That dataset has about 105,000 documents, web documents. So that's a quite small corpus. Do you agree? Right? Most enterprises have more data than that. If you convert those 105,000 documents, you end up with about 740 million LLM tokens. And the current models are restrained by the attention mechanisms of the transformer architecture in terms of compute. So the current frontier models only have up to 1 million, right? So, and retrieval is essentially allowing a model to kind of soft attend to a much larger number of tokens. And for me, relevancy is about trying to figure out which of the tokens should actually fit into the context window that the model should actually attend to. And I see that as a relevancy, classical relevancy task. And doing on the same benchmark, if you, and this benchmark, by the way, is like very hard. There's like 830 different questions. They are almost like a pub quiz questions or riddle-like, very long. And in order to find the answer, which is relatively short, you have to gather evidence across multiple different web pages. And if you evaluate the answering accuracy of the total system by just stuffing all the relevant evidence into the context model, even GPT-4 can answer with a very high accuracy. Right? It gets all the questions right. So if the evidence documents are in the context window, it's actually able to answer those questions almost perfectly. But if you give the model or the agent access to retrieval, and when you have, like, don't think too much about this BM25 baselines because there are different baselines, but there's an accuracy gap here, right? Which for me translate that retrieval is actually one of the key bottlenecks to solve relevancy, and not so much modeling reasoning. Right? It's the same LM, but the difference is in what is in the context window. And the retrieval layer then essentially decide what gets into the context window. And with loops, probably there are people here working on e-commerce search, some. And you probably have a lot of stuff going on in production to capture what users are clicking on. And you're probably also training models on that data. Yes. And why is the reason we are training on this log data? Because users don't really like to give feedback, right? So if you say, rate these search results, nobody's going to click it. When I go to the post office, I get an email picking up a parcel, and it's like, after I get a rate your experience. I don't want to do that. So we built this whole infrastructure layer, like to try to capture what people are clicking, what people are skipping, what people like, how long time, or they put it to the chart, etc. But now we have a new user, right? An agent. They are not so lazy. If you instruct them to give feedback, they will give feedback, a lot of feedback if you want to. And that can kind of change a little bit in how we think about the loop. Obviously, if you're used to working on relevancy, you have things like trying to come up with judgments. So judgments is essentially a pair of a query and a document, and you have some way to evaluate if this document is relevant to the information need, and you can have grades and you can whatnot. And you can calculate some metrics like looks good to me. That's probably the most common used metric in the industry. Then you have all sorts of more formal metrics as well. One interesting aspect here is that to evaluate relevancy, you also have to, to measure your system, you have to have queries that are kind of representative for the workload that you're actually seeing, right? The actual users, and the user is new. And the fun observation I'm making is that most of the information retrieval benchmarks are outdated because they assume there's only one query, right? If you look at beer, MTab, these kind of benchmarks, if you're choosing an embedding model, you're likely like, oh, let's go to see MTab. And GCD, okay. It's like, there's like a 1.8 billion parameter model, 4,096 dimensions, and all kinds of cost problems. But it's actually just measuring like some human user that sometime typed one query and got one result back, right? What if you allow it to do a second query, right? I think that's very interesting, because I think with this, that also simpler tools becomes more powerful because you have a more powerful user. I mentioned grep, and if you've seen how Claude Code is doing grep, or the model behind it is doing it, it's quite amazing, using a lot of syntax and things that I have no clue about. I would never typed out like 100 different ways of formulating the problem, right? So, yeah, I think most of the benchmarks out there are kind of built for a human user typing one query. And I think this is a good thing to think about relevancy is like evaluation starts with the job to be done. That you want these queries that you are measuring to actually match the real user. So a human user or agent user, right? And then you want to find a metric, which is hopefully a good proxy that is something you can measure to this job to be done. And in order to calculate this metric, you also need something to judge, right? So in the case of BrowserComp, you're judging the accuracy of the overall pipeline. And then you might have some constraints around the cost of putting this to production versus how well it works. Lester, one of my colleagues and co-founders, is giving a talk later tomorrow on when better retrieval makes agents worse. And he will deep dive into relevance evaluations and so forth for agents as a new user. So I won't cover that so much here. But the key observation is that agents can actually rate and give judgments. If you look at some of the information retrieval benchmarks out there, you can also see that agents or LLMs usually are agreeing with human evaluators, right? Also LLM as a judge. As long as the LLM as a judge is kind of pre-calibrated, you can actually get quite good alignment between human evaluators and LLM evaluators. And if you want to learn more about that, you can also look at my previous Berlin Buzzword talk on that topic. And this is, I think, is refreshing because it also means that these companies that are building all this kind of infrastructure to capture all these kind of signals, that's quite expensive to do, right? While the rest of us that don't have that type of infrastructure, we also want to build great search, right? And how can we do that? And how can we build great search for agents? And I call this pseudo-relevance feedback on steroids, because in classic information retrieval, you have this method that is called pseudo-relevance feedback, and it's called pseudo because you're simply assuming that the first query is returning something that is relevant, and then you extract all the terms out of those documents and you repeat the query. Now we actually have a user that can actually judge the results of the first query and then change the query, which is quite powerful. Which intros to how we can kind of build self-optimization loops. There's a pattern called auto-research. It was kind of invented, or at least talked about, from Andrej Karpathy, a famous model and educator, model trainer and educator, where you simply give a coding agent some kind of metric that hopefully aligns with the work you want to get done or the task to get done. And you have a set of tools, and you have some kind of verifier that can verify the results, that it's improving or not. And then you can let the model kind of keep the change or discard it or try another experiment. And I think this is a quite interesting thing. I've used this for a lot of different experiments, like improving serving performance, improving relevancy, all kinds of things that you can kind of give away to the coding agent and you can really explore. And with that, actually, retrieval infrastructure that we are building becomes like a reinforcement learning environment. Because if you make that infrastructure kind of programmable and verifiable, it's quite easy to kind of hill climb on the metrics that are aligning with your kind of work to get done. This is something we are kind of betting the company on. So I think this is powerful because you can optimize a lot of different metrics. That said, I think the kind of action space, the model is trying different things. You should try to make it small enough so it's easier for the model to reason about. So when I have interns that are working with us, they always want to try to optimize everything like in one go. And I say, If you have too many parameters, it's very difficult to understand which parameters actually move the needle or not. So it could be good to not expose all the knobs that you can, but a few at a time, so you can try to optimize. I think this, if I drag this, something happens or not. Oh, something. Let's see. Yeah, so the case there to have like not so many outcomes is that you can start with a baseline, and then you can keep this first metric, and you keep this visible for the coding agent. And then you can have the coding agent kind of inspect that eval, and then can change some configuration. So to be concrete, this could be, for example, hyperparameters for BM25. Not sure if any of you have actually tried doing that. Now you can in a very easy way. And then you can let it like rip through and try different changes and reject any kind of improvements that are not kind of accepted within the constraints you set. But this can fail quite miserably because they are also eager because of the way these models are trained. They really want to satisfy you. They really want to make you happy. So they might start cheating, looking around for ways to improve the metrics. So I had many times in this loop where it ends up writing some custom code that is not supported, that I didn't want. So you want to avoid that. And you also want to avoid, I mean, in classical machine learning, you always have like some training data set, and then you also have some kind of eval holdout, right? So you can train on this data, and then you can evaluate if it generalizes to eval, not evil. And yeah, so I try to be funny here. Like I improved recall by deleting the hard queries. You can totally have that happen. You don't want to need that. So you still need some kind of guardrails. And this kind of reinforcement learning environment is more on the offline stage of optimizing something, while pseudo-relevancy on steroids is more for the online part of this. And it ties into kind of how we structure and how we lay out the underlying things that the model actually can change, either in the offline stage or in the online stage. In the offline stage, you want to have some kind of action surface that the agent can like safely modify without breaking your production system or without breaking things. And you need this kind of verifier evaluation strategy, which might be a human in the loop, or it might be a LLM as a judge. And you need some kind of observability for the agent to see the changes it's making and what the impact is. This could be, for example, the scores or score distribution, things like that, especially for relevancy. So that was on the offline stage where you can use retrieval infrastructure as a reinforcement learning environment. But I also think that on the query side, if you keep kind of exposing search or retrieval as a primitive to the model, and you're choosing the simplest form of abstraction, which is just exposing here, you can pass a query string here, and you get some results back, then the agent is only able to reformulate the query, right, during the pseudo-relevancy feedback pair. If you expose more of the surface, like the domain-specific query language, the agent can actually use more of the power of the retrieval engine. So let's say, here's this query. I'm going to choose to use semantic or embedding-based retrieval. Or I'm going to use a reciprocal rank fusion for this type of query, right? So you allow the model to be more expressive. I think that's a clear direction, because the models are getting better and better and better, and just trying to confirm them to the same kind of human level abstractions won't work that well. That was what I had. I also want to remind you that I'm a part of a panel later today. I think that's going to be fun. On AI is here and time to throw away our search engines. So you should come just before beer later on. And also, if you want to talk to me or you didn't like my talk, you can yell at me on Twitter or email, or you come see us outside here. And now I'm happy to take questions. So we have good chunk of questions.
Thank you. Yeah, questions. So there's already one there.
Thanks, Joe. That's a great talk as ever. Interested when you were talking about this analogy between standard Google search and the advanced search page.
Yep.
There's some analogy I've used myself. I think the advanced search page, for me, that always seems to align with certain use cases. For example, in what we might call professional search, patent search, medical search, that kind of thing.
Yep.
Do you think this kind of agentic retrieval is well suited to these use cases, or more suited to those use cases, or is it just a general strategy that will apply to all kinds of searches if they're driven by agents?
I think it will apply to a lot of different domains. So you mentioned a lot of key domains. I think obviously Google is about like a horizontal access to data, where they made it really easy for a lazy user to come in and type 2 words and you get a reasonable good result. I think we are moving towards the new user that can express more power, right? Not in just how it formulates the query, but getting access to how do I weight various components. Should I use semantic? Is like a big thing like hybrid search. So I think it applies to a lot of different domains. But we only we are just at this shift, right? I think all of us just started to believe in agents around December, Cloud Code, holidays. We have been talking about agents for a long time, and people said, yeah. But after Christmas, a lot of people say, oh, now I understand. Agents is a thing. So it's still like emerging. Thank you, Charlie. And soon they will also be able to use a browser, right? So the browser interface, they're not so good at it at the moment, but they will be better at that as well, right? So, but just to illustrate the abstraction differences.
Thank you for the nice talk. Navid from Thomson Reuters. Basically 2 questions. One is that we've get used to very convenient non-deterministic evaluation methods with the old-fashioned search engines.
Yep.
Now that we are moving into non-deterministic situation, how would you see that we should adapt our evaluation? This is my question 1.
Yep.
And the second question is that the general approach to search has been well-crafted methods that works really well in terms of efficiency and effectiveness. I'm a little afraid that we start becoming token consumers by just making the search system worse and worse, but let the agent just solve the problem. So we kind of like we kind of just let the problem being solved that can be solved actually with more care into an agent. What would your view on that, or any solution you can talk
right about? So I think first of all it's a great question and multifaceted, and let's tackle the first one, which is about reproducing something, right? If you let the agent is doing his thing. If you remember the browser comparison, we are evaluating the kind of the key metric we're evaluating is if the system is able to answer the question correctly at the end, right? So that's the kind of the goal or the task to be done, right? What's the accuracy number that you look at on the outside, right? And then you can change, like, how do you change the tools for the model? Like, do you use BM25 or use vector search or other methods, right, to get to the answer? So you can like reason about that as a human researcher. And you can see how many tokens have this kind of system consumed to get to the correct answer. And obviously, the system then can get you to the correct answer with as few tokens as possible is the obvious winner, right? There's trade-offs between cost and latency. And then there's the thing about like, oh, should we just let agents rip through and do pseudo-relevancy feedback? And we can't really control what they're doing and what's the latency involved in that, et cetera, I don't have the answer to that, right? Because what we can see is that in general, in the coding domain, we've seen that we can kind of remove more and more of the harness around the model. Like we don't need a read tool to let the model read a file because it just can use bash to cat file, right? So you see a lot of these harnesses are actually shrimping the surface because the models are getting better and better. And I predict that for search, so far we just exposed a search tool for the model. I think the same thing will happen there, that we can expose more of the raw functionality and more towards letting the model rip. I hope it answered some of the parts.
We have time for, I guess, 1 or 2 more questions. Yep.
When I see optimization, I see a multi-objective problem in which there is many multiple solutions. How do you manage to make the agent explore all the solution space?
Yeah, so that's a great question. So I think there are a lot of things that are not covered at all in this talk. Here we've been talking about relevancy as in text data or other data. We only looked at one objective, which is like the relevancy. In other domains, there are other objectives like revenue, like the number of checkouts, et cetera, et cetera. But that's also interesting because you can kind of envision that some of this prior knowledge can also be added to the context of the model, right? So the revenue of this item, it's better if you can actually put this a little bit in the context that, guide it towards a multi-objective problem, at least if you are at the stage where you cannot really train your own agentic search model, right? Which could incorporate this as a signal as standard kind of multi-object or multi-objective optimization techniques, right? So, yeah. There's only so much you can pack into 30 minutes, but that's a great question. And I also wonder about, like, one of the key things that I wonder about, like, how will memory look like for a retrieval agent? So an agent that is doing retrieval and calling all these methods, like, if it's dumb, like, there's a new user searching for thing, and I had to do 10 calls to get the right answer, how can I update my memory of this so that the next user that asks the same question, right? So I think memory for retrieval, there's a lot of memory databases, whatnot, but I think memory for retrieval and this kind of behavior is quite interesting as well. But we're all kind of learning on the job, so I don't have all the answers. You might ask why I call it retrieval and not search. So my mom, if I say we're building a search engine, she thinks we're building a new Google. So we prefer to use the term retrieval engine and not search engine, because she easily gets confused, thinking that we are building a consumer-facing product, and we're not. So. Yes?
Last question.
Yeah, thanks a lot for the talk. I was just wondering, I think like in traditional search, we really converge into like retrieval part and ranking. So I think that's pretty clear. However, I think up until now, I've heard only agentic retrieval. What do you think about that? Do you think that like let's say like agentic ranking, is it included in the agentic retrieval that we implicitly kind of thinking about now, or we are not there yet? Thanks.
Right, that's a great question. A lot of you people that have been working in search for a very long time, you think about retrieval and multi-phases of ranking, etc., and probably you have different systems and microservices and whatnot. When I talk about retrieval, I talk about the whole chain. So when I talk about the agent expressing a search, I'm talking about potentially the whole chain of events you're doing to do candidate retrieval, re-ranking, diversity, and whatnot. But an interesting question is, should you maybe expose that directly to the agent itself, like giving some code primitives to actually express things like diversity, candidate retrieval, multi-arm candidate retrieval, how do you express ranking, etc. Maybe that can be let to the model as well. Yeah.
Great. Thank you very much.
Thank you
Big
so
round
much.
of applause for Jo Christian.
Thank you.